Hi and Assalamualaikum. In this subtopic, a student should be able to explain Kepler's law, express Kepler's third law that is T square is directly proportional to R cube, and solve problem using Kepler's third law. Kepler's third law. The square of the orbital period of any planet directly proportional to the cube of the radius of its orbit, or law of periods. A planet which orbits with larger radius has a longer orbital period. Planets which are further from the Sun take longer time to complete one orbit around the Sun. For example, Earth takes years to make one complete orbit while Saturn takes 29.5 years. Figure shows the orbits and orbital periods of planets. Kepler's third law can be formulated using Newton's universal law of gravitation and concept of circular motion. Planets make circular motion around the Sun. The centripetal force is the same as the gravitational force between the Sun and the planet. Observe figure which shows the orbit of a planet around the Sun. Assuming that the orbit of the planet around the Sun is circular, we can derive the relationship between the orbital period of the planet and the radius of the orbit as in Kepler's third law. Gravitational force acting on the planet, that is F equal to gmm over r square. The gravitational force acts as a centripetal force for the planet to make circular motion around the Sun. Centripetal force F equal to mv square over r. Therefore, centripetal force is equal to gravitational force, that is mv square over r equal to gmm over r square. V square equal to gm over r, equation 1. Linear speed of planet v equal to distance traveled in one complete orbit over orbital period, that is 2 pi r over t, equation 2. Okay, substitute into 2 into 1, 2 pi r divided by t square equal to gm over r, t square equal to 4 pi square over gm times r cube. As gm is constant, t square directly proportional to r cube, and t square directly proportional to r cube is Kepler's third law. When Kepler's third law is applied in the system of planet and the Sun, m is referred to as the mass of the Sun. Kepler's third law can also be applied to the system of satellite and the Earth, with m referring to the mass of the Earth. Figure shows the formulation of Kepler's third law. Kepler's third law, that is t square directly proportional to r cube, can be formulated by equating centripetal force and gravitational force. Substitute v equal to 2 pi r over t. As such, the relationship between orbital period of planet t and radius of its orbit r is t square equal to 4 pi square over gm times r cube, where the constant k equal to 4 pi square over gm. Solving problems using Kepler's third law formula. From Kepler's third law, relationship between orbital period t and radius of orbit r is t square equal to 4 pi square over gm times r cube. Compared to planets. For planet 1, t1 square equal to 4 pi square over gm r times r1 cube, equation 1. For planet 2, t2 square equal to 4 pi square over gm times r2 cube, equation 2. Equation 1 divided equation 2 give t1 square over t2 square equal to r1 cube over r2 cube. The equation t1 square over t2 square equal to r1 cube over r2 cube can be used to calculate the orbital period t of all radius of orbit r. Example 1. Figure 3.30 shows the planet, Earth and Mars orbiting the Sun. The radius of the orbit of the Earth is 1.50 times 10 power of 11 meter. Orbital period of the Earth and Mars is 1 year and 1.88 years respectively. Calculate the radius of the orbit of Mars. Step 1. list the given information in symbol. Radius of orbit of the Earth R1 equal to 1.5 times 10 power of 11 meter. Radius of orbit of Mars equal to R2. Orbital periods of the Earth T1 equal to 1 years. Orbital period of Mars T2 equal to 1.88 years. Step 2. Identify and write down the formulas used. T1 square over T2 square equal to R1 cube over R2 cube. Step 3. Substitute numerical values into the formula and perform the calculation. 1 square over 1.88 square equal to 1.5 times 10 power of 11 cube over R2 cube. R2 cube equal to 1.50 times 10 power of 11 cube times 1.88 square over 1 square. R square R2 equal to cube root of 1.50 times 10 power of 11 cube times 1.88 square over 1 square. The answer is 2.28 times 10 power of 11 meter. Example 2. Figure 3.31 shows that a research satellite needs to orbit at a height of 380 km to capture clear image of the surface of the Earth. What is the orbital period of the satellite? Radius of the orbit of the Moon is 3.83 times 10 power of 8 meter and orbital period of the Moon is 655.2 hours. Solution. Radius of orbit of the satellite R1 equal to 6.37 times 10 power of 6 plus 380 times 10 power of 3 equal to 6.75 times 10 power of 6 meter. Radius of orbit of the Moon R2 equal to 3.83 times 10 power of 8 meter. Orbital period of the satellite equal to T1. Orbital period of the Moon T2 equal to 655.2 hours. T1 square over T2 square equal to R1 cube over R2 cube. T1 square divided by 655.2 square equal to 6.75 times 10 power of 6 cube over 3.83 times 10 power of 8 cube. T1 square equal to 6.75 times 10 power of 6 cube times 655.2 square divided by 3.83 times 10 power of 8 cube. T1 equal to square root of 6.75 times 10 power of 6 cube times 655.2 square over 3.83 times 10 power of 8 cube. The answer is 1.53 hours.